Dear students, now we are going to see the subject transmission lines and RF system. Under that, the topic is quarter wave lines. On completion of this quarter wave line, the students will be able to define the quarter wave line and write the expression for a quarter wave line and list the applications of quarter wave line. Quarter wave line means the length of the line is lambda by 4. Lambda represents the wavelength. It is represented in this figure. The length is represented by lambda by 4 and the end of the line is terminated by the receiving end impedance or the load impedance ZR, and the line is supplied by the source of energy ES. The transmission line length is lambda by 4 and the input voltage is ES and the current is IS. The input impedance of the circuit is Z input. The receiving end voltage and current is ER and IR. The distance between sending and receiving end is lambda by 4. The input impedance of the lossless line is given by Z input is the ratio of sending end voltage to current, that is equal to R naught into ZR plus J R naught tan beta S divided by R naught plus J ZR tan beta S. Here substitute S is equal to lambda by 4 and beta is equal to 2 pi by lambda in the above equation. So input impedance equal to R naught into ZR plus J R naught into 2 pi by lambda into lambda by 4 divided by R naught plus J ZR tan 2 pi by lambda into lambda by 4. Simplify this. So input impedance equal to R naught into ZR plus J R naught tan pi by 2 plus divided by R naught plus J ZR tan pi by 2. If the value of tan pi by 2 is infinity, so from the numerator and denominator keep tan pi by 2 as common. So input impedance equal to R naught into tan pi by 2 divided by tan pi by 2 into ZR by tan pi by 2 plus J R naught divided by R naught divided by tan pi by 2 plus J ZR. So 1 by infinity is 0. So the term input impedance equal to R naught squared by ZR. The input impedance equation is similar to the equation of transformer. Thus the quarter wave line can be used as a transformer for impedance matching to the load ZR with the input impedance Z input. The quarter wave transformer can transfer a low impedance into high impedance and vice versa. So it can be considered as impedance inverter. The short circuit quarter wave line behaves like a open circuit in the other end, while the open circuited quarter wave line behaves like a short circuit in the other end. Applications. The major application of quarter wave line is impedance transformer is coupling a transmission line to a resistive load such as an antenna. From the input impedance equation of quarter wave line, the input impedance equal to R naught square by ZR. If antenna has a load having a resistance of RA, the quarter wave section is designed such that its characteristic impedance is R naught dash. Transform the antenna resistance RA to the characteristic impedance of the line R naught. So R naught is equal to R naught dash square by RA. So R naught dash square is equal to R naught into RA. So R naught dash is equal to square root of R naught into RA. One of the possible quiz question is the condition for a quarter wave transformer is Z naught square is equal to input impedance into the load impedance. Thank you.